All right, question number 9, another straightforward question, and that's from rotation. A slight amount of calculation is involved. However, that's never an issue. An inclined plane of inclination 60 degrees is given, and a ring and a disc rolls without slipping. And they are released at the same time. And it's also said that the time difference between their reaching the ground is this much. And we need to calculate the height of the top of the inclined plane. So the situation is very, very straightforward, a formula-based question, a regular formula that we do in the class. So let's say here is the inclined plane, and the angle of inclination of this inclined plane is given to be 60 degree, and let's say this height is h. Now, if I have a ring, disc, whatsoever, which rolls along this inclined plane, the acceleration is a very straightforward formula, right? The acceleration comes out to be A equals to G sine theta divided by 1 plus ICM upon MR square. A regular feature question, so there should be no requirement of additional explanation for this. Now, let's go. Let's take turn-wise turn. Let's first talk about the ring. If I talk of ring, AR, that's going to be G sine theta divided by 2. For disc, this is 1 by 2. So, acceleration of disc, that's 1 by 2. So, that will be 3. That's equals to 2 by 3 G sine theta. All right. Now, the question is so easily done. This is h. So, this will of course be equals to, let's say, I can write h upon sine 60. And that's equals to 2h by root 3 is this particular length. And does it require any further additional support? I don't think so. Otherwise, if you see the distance is, you know that L will be equals to 1/2 of a t square. L is the length along this. Acceleration for ring is this. You can find the time. You just need to subtract, as I have already said. Conceptually, we are done. It requires a slight of calculation, and when you solve that, the value of h comes out to be 0.75 meter. So, 0.75 would be the correct option for this question number 9. All right, time to move to question number 10. Let's see. Moving to question number 10, another straightforward question from simple harmonic motion. So, a spring block system is resting on a frictionless floor as shown in the figure. So, let me show you the figure then. That's very required. So, here is the given situation. 1 kg block, 2 kg block, spring is there, right? So, now just remember this figure. I need to scroll up. So, here it's something like this. The spring constant is 2 Newton per meter. So, and the mass of the block is 2 kg. Ignore the mass of the spring. So, here it's given. This is 2 kg, and the spring constant, that's given out to be 2 Newton per meter. That is the spring constant, which is K. All right, let's see now. Initially, the spring is in an unstretched condition. Another block of mass 1 kg moving with a speed 2 meter per second collides elastically with the first block. So, the block collides elastically. Okay, elastic collision, that means E equals to 1. The collision is such that 2 kg block does not hit the wall. This does not go and slam the wall. That means it reaches a maximum compression, then it returns. The distance in meter between the two blocks when the spring returns to the unstretched position. That means this continues, and let's first try to figure out. Initial velocity of this is 2 meter per second, this is 0, and let's try to find out what would be the final velocity. So, this time you see, just by elastic formula, if you remember, the velocity, this will be 2 by 3 and this velocity will be 4 by 3. Now, this is the part that I would be expecting that you can very easily calculate the velocity for an elastic collision, right? So, one is 2 by 3, one is 4 by 3 meter per second after collision. That means this 1 kg block, this after collision would straightforward start moving in this direction, and this 2 kg particle would go there and come back. And by the time the 2 kg comes back, let's see what distance would 1 kg have traveled. The 1 kg block would have traveled a distance of 2 by 3, because after rebounding the velocity will not change, the surface is smooth. 2 by 3 multiplied by the time, and that time is pi root m divided by k. That's how it goes, right? Because this goes there, maximum compression, and comes back. That's half of the period. So pi root m by k. And in this time, this would have moved this particular distance because it rebounds with a speed of 2 by 3. So this one is the value, and when you solve this, the value would be rounding off to 2 digits after decimal, 2.09. So this would be the correct option for question number 10. Let's move to the next question, question number 11.